Okay, so what we're doing is just a little scientific notation and a couple of negative exponents in here. You got this, that's 50 million times 4.2 times 10 to the 21st. Let's just make sure we totally understand. Okay, first of all, 50 million is 5 times 10 million, right? Now, how many tens do we have to multiply out to get 10 million? Well, you count zeros and see. Let's make sure we understand. So, that's 1, 2, 3, 4, 5, 6, 7 tens multiplied together. That's, and we're going to just go ahead and group them in twos. That would be 100 times 100 times 100 times 10. And 100 times 100 is 10,000. And 100 times 10 is 1,000. And that does come out 10 million. You got 3 zeros here, 4 zeros here. Every time you multiply by 10, you start just 10 times 10, that gives you 2 zeros, that's 100. Multiply by another 10, that gives you another zero, that's 1,000. Then 10,000, 100,000, a million, 10 million. And of course, that's 10 to the 7th because this is 10 to the 7th, right? Got to multiply 10 by itself 10 times to get this. So it's 10 to the 7th. It's not just a matter of counting zeros. You really want to understand where all those zeros come from. And it's simple. Every time you multiply by 10, you get another zero. Okay, so make sure you understand it at that level or it'll get away from you. Then $15 million, that equals 5 times 10 to the 7th. And that's 5 times 7, 10 to the 7th, and then times 4.2 times 10 to the 21st. Now just make sure we understand what's going on. We rearrange this. And you don't necessarily need to write out this step, but make sure you understand it. We have 4 numbers multiplied together. We can multiply them in any order. We can group them as we wish. So we group the 5 and the 4.2, and that equals 21. And then 10 to the 7th times 10 to the 21st by the rules of exponents. We have the same base. We simply add the exponents. We get this. 21 times 10 to the 28th. Now we're really close, but remember that this number has to be between 1 and 10. Can't be as much as 10. It can be as small as 1, okay? 21 is 2.1 times 10. Writing out the exponents explicitly. 10 is just 10 to the 1, and we have 10 to the 28th. And we end up with 2.1 times 10 to the 29th. Okay. Now, you don't necessarily have to go through all this, but you should understand all this so you really understand what's going on instead of just running around counting zeros and so forth, okay? And make sure we understand how the rules of exponents apply. Okay, the second one we'll do a little more quickly, 3.7 times 10 to the negative 46 times 2.8 times 10 to the 34th. Just to distinguish the two numbers, I was tempted to put parentheses around them and didn't, but I just did, okay? So we're multiplying this number by this number. Well, take these two numbers, multiply them together, take these two numbers and multiply them together. I should have chosen numbers that are easier to multiply together. Let's see, 3 times 3.7 would be 11.1. Yeah. 10.2 times 3.7 would be 0.74. 11.1 minus 0.74 is 10.44. 1.36. Question mark over that one. And then this is 10 to the negative 46 plus 34. That's the rules of exponents. Negative 46 and 34 is negative 12. I have 10.36 times 10 to the negative 12. Of course, 10.36 is more than 10. So we have to write that as 1.036 times however it is 10 to the 1 multiplied by 10 to the negative 12th, which comes out 1.036 times 10 to the negative 11. I skipped the step where I write 10 to the 1 minus 12. I think we understand that. If I've done this correctly, let's make sure I've got it right. That's a 10 to the negative 12. That's a little more than 10. So that's going to give us 10 to the negative 11th. And check my arithmetic on this. Okay. Now, if I want to write this number out, leave myself room to write it. So I'll do that at the end. Let's just go ahead and work through this last one. And the problem is it's 57 billion times 7 100,000ths. So we count zeros, well, we can count digits all the way back to whatever, all the way back to this place. We got 3, 6, 9, 10. So that's 5.7 times 10 to the 10th. Multiplied by 7 times 10 to the negative 5th. 5.7 times 7 then, times 10 to the 10th, times 10 to the negative fifth equals 39.9 times 10 to the 10 minus 5. And I'm going to combine steps a little bit. That's 3.99 times 10 to the 1, multiplied by 10 to the 5th, which comes out 3.99 times 10 to the 6th. Let's make sure that makes sense. I've got 10 decimal places here. I've got 5 decimal places to the right of the decimal place, decimal point. And that's going to leave me like 3. Wait a minute. I'm not counting right. That's 10 minus, yeah, that leaves me 10 to the 5th. And then 7 times 5.7. I'm saying it's 3.99. I'm pretty sure of that. But still, there's always a question mark when I do arithmetic in my head. Okay. Okay, so first result. Okay, now I'm going to need a bunch of zeros here. I don't want to write the intermediate. It'd be 2.1 times 1 followed by 29 zeros, which is going to be 2, and then 29 decimal places to the right of where this decimal is. This is the first, second. Okay, so you see this is a lot easier to write than this. And then we put some commas in here. Make sure I've got the right number of zeros. That's 3, 1, 2, 3. 9 groups of zeros, that's 27 zeros. There's a 28th, and then another place where the decimal place was. Okay? All that makes sense? It should be clear why we use the scientific notation instead of writing out all those zeros. It's easier to keep track of the exponents than it is to keep track of all the zeros we might want to write down. Okay? And of course, your calculator, when you get a number that big, is going to just automatically go into scientific notation. And that it would write that, incidentally, as 2.1 P29. P standing for the exponent of 10. It usually won't write 21 times 10 to the 29th. 2.1 times 10 to the 29th. Okay, well, if we want to write this one out, we're going to get, if my multiplication is correct, 10.36 times 10 to the negative 12. Well, sorry. Copy down what I wrote, which is 1.036 times 10 to the negative 11. What I got down there. That's too far away. I couldn't see it over there. Okay. And that's, then we take our 1036, just like we got a decimal that used to be here, we got to count over 11 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And here we have it. Okay. So we need to understand all that. And of course, the last one's easy to write out in scientific notation. Wherever I did it here, just move this decimal over 6 places. Everybody okay with that? They seem to have done pretty well with it, but there were a couple of little glitches. And I might have one that, like I say, check my multiplication, make sure I've counted the zeros correctly, stuff like that. Okay. Now, we've also got the whole idea of negative exponents. Let's try to simplify a couple of things. I'm going to let you do, it's not a quiz, but I want to see what you do with it. Okay. So let's try. Simplify that. Okay, so what do? Well, we have to raise this to the negative third power, raise this to the 7th power before we can start combining them. So we're going to get x squared to the negative third times y to the 5th to the negative third times x cubed to the 7th times y squared to the 7th. That makes sense? Because of course, negative 3 power applies both the x squared and the y to the 5th, there it is. And the 7th power applies both to the x cubed and the y squared. So that's going to give us x to the 2 multiplied by negative 3, y to the 5 multiplied by negative 3. Times x to the 3 times 7, y to the 2 times 7. And I recommend, until you get really used to the laws of exponents and the rules for exponents, that you write out this step to reinforce that you're multiplying this by this, and so forth. If you write this out every time you do a problem, then you're not going to get mixed up when it comes test time and you're under pressure, okay? So anyhow, 2 times negative 3 is negative 6. That's y. 5 times negative 3 is negative 15. And of course, you can see that. You can see 2 times negative 3 is negative 6. 5 times negative 3 is negative 15, right? If you really are confident, you can skip some of these steps. But again, until you've done a couple dozen problems, I don't recommend skipping steps because it sticks with you better if you don't. And it doesn't take that long to glue everything together by writing out the steps and reminding yourself of what you're doing. And how you have x to the 21st now and y to the 14th. Now that's x to the negative 6th times x to the 21st multiplied by y to the negative 15th times y to the 14th. And it's really good to, again, explicitly show that you group the x's together and group the y's together. Okay. Not everybody did that, but many did. And of course, you know how to do that today. You're going to know how to do that 6 weeks from now. Okay. If you write out all the steps, you're going to be more likely to remember. Anyhow, then this is x to the negative 6 plus 21 times y to the negative 15 plus 14. As a rules for exponents, so you're going to add these exponents. And again, if you go back to x squared times x cubed an x squared cubed, which is the first thing I showed you when we started talking about exponents. You can always keep straight whether you're going to add or multiply your exponents. Okay. Make sure you kind of have that as a touchstone. Okay. Anyhow, this gives you x to the 15th, y to the -1, or x to the 15th times 1 over y to the 1, which is x to the 15th over y. Again, you really want to understand these steps and not just do it by habit. By all means, do it by habit, but then think through the steps and make sure they're right. Does that make sense? Okay, well, that's quite a bit about the whole idea of negative exponents and so forth, but you don't want to stumble over negative exponents, so make sure you understand all this. Okay, what we want to do is figure out x plus y squared using the distributive law, and then x plus y times x minus y, again, using the distributive law. Take a minute and do that. Now, it's important to understand what x plus y squared means. It means x plus y multiplied by x plus y. So once that's written down, the distributive law takes care of the rest of it. That's really tempting to say that this is x squared plus y squared, but that's not the case. That's not what this means. It means x plus y multiplied by x plus y. And when you multiply x plus y, you get x multiplied by x plus y plus y multiplied by x plus y. It's x times all this plus y times all this. So there's another way you could have written it out, but I'll choose to just stick with this one. And then when you multiply this, you get x times x plus x times y. And here you get y times x plus y times y. And I kind of knew when I wrote this down that I hadn't left myself enough room. So it's x times x. Okay, x times x is x squared. Now we have x times y and y times x. Let's write y times x alphabetically as x times y. Because commutative law tells us it doesn't matter in which order we multiply these. And if we do that, we see that this term matches this term. And then this is y squared. Well, xy plus xy is 2xy. And that's y squared. Now let's look at an example here. Let's say we've got 5 plus 3 squared. Of course, that's 8 squared, which is 64. Now, 5 squared plus 3 squared is 25 plus 9, which is 34. So clearly, if you square 5 plus 3, you don't get 5 squared plus 3 squared, right? It's not going to work. It's not going to work because you're missing the 2xy here. So I'm going to cross this out. say almost never do you do this. The only way you could get away with doing that is if one of these numbers was 0. Okay. Now, according to this formula, five plus 3 squared, if x is, you let x stand for 5, and you let y stand for 3, and you see that this expression here, x squared, is then going to be 5 squared. Y squared, of course, will be 3 squared. But you've got this 2xy here, which is 2 times 5 times 3. If you do that, you get 25 plus 30 plus 9, and you can check that out, and it adds up to 65. That works. This doesn't. So there's a special product. Now we'll stick with this one for a minute. Let's say then that you have 5a plus 3b squared squared. If you let x equal 5a and let y equals 3b squared, you have this. So what is 5a plus 3b squared equal? Well, it equals x squared plus 2xy plus y squared if x equals 5a and y equals 3b squared, right? And that has to then be 5a squared plus 2 times 5a times 3b squared plus 3b squared. Okay? Because we've agreed x is now going to be 5a and y is going to be 3b squared, just for the moment, just for this problem. But we're going to make this assumption so that the square of this has to equal this, which comes out this. And now we do the squares, we get 5a squared plus 5 times 3 is 15 times 2 is 30. And it's a times b squared. And this is going to be then 9 d to the 4th. Without going through the details of explaining how to square this term, which I think everybody's pretty good with. Okay? Make sense? Okay, so do this one for me. Three z minus 4q squared. Now I want you to write out the step. Including all my words, this is x plus y squared with x equal and y equal. Express what x is, express what y is, and then continue. So write out all my words and then complete. Process of working this out. Okay, some people love the distributive law too much, and they're trying to use the distributive law to do this, which can be done. It's not difficult, okay? But what we're looking at is a way we can expedite things a little bit by not using, but by using the special product that we've developed up here. Okay, and this is a special product. X plus Y quantity squared equals this, okay? And this is an example of X plus Y quantity squared if X equals 5A and Y equals 3B squared, okay? And if we do that, then we can just plug 5A and 3B in for X and Y so that our X squared plus 2XY plus Y squared becomes square of this thing plus 2 times this thing times this thing, that's X times Y, plus Y squared, which is just this thing squared, and there it is, okay? Okay, so here we're trying to imitate the same thing, which is why I said, write out all my words, okay? So kind of focus on that. If I ask you to write out all my words, it's going to lead you along a thought process. It's going to be beneficial to you, okay? Use all my words. And when you do problems like this, use all my words. Now, if you see words you like better, like in open math, go ahead and use them. But show me all the logic and reasoning that goes with this, because that's how you retain it, okay? You don't just write the symbols down that look right and get in the habit of doing that, because if you don't understand the logic of what's going on, it's not going to stick with you as well. Okay, so again, write out all my words. I'm saying this more for my distant students than I'm saying for us. And you know, many of them probably aren't even watching these lectures. They're getting it from open math. It's hard for me to tell what they're doing, but I see evidence in the uploads they give me. Some of them are paying attention to what I'm saying too. It's okay, but I think this is the route to understanding. If you really understand the logic and want to write it out a little differently, okay, but write it out. Okay. Well, in any case, okay, this is X plus what this is this, as long as X equals 3Z and Y equals negative 4Q. So equals X squared plus 2XY plus Y squared, because we've already done the distributive law up here. And it always applies, as long as we understand what X is and what Y is. So what is X squared? Well, X is 3Z. So we've got 3Z quantity squared. And that's 2XY. That's 2 times 3Z times negative 4Q plus negative 4Q squared. Now we could then say this equals then 3 squared times Z squared, but it's easy enough to see if we square 3 and square Z, we're going to get 9Z squared. And when we multiply this out, we're going to get a Z cubed, and 2 times 3, 6, multiplied by negative 4. Our numbers multiply out to negative 24. We square negative 4, we get 16. We square Q, we get Q squared. And then we could write that as 9Z squared minus 24 Z cubed plus 16Q squared. Then you could go ahead and do this with the distributive law. And if you don't get it, figure out what went wrong. Did you use the distributive law wrong? Did you use the special product wrong? Or, heaven forbid, did you do both of them wrong? Okay. Now, if you write all this out, it probably takes just about as long as it would if you use the distributive law. Okay. But ultimately, when you really understand the logic of it, it's just a two-step process. You identify X, you identify Y, and then you don't have to write this out. You know what this is. You just write this out and get your result. And it is quicker than the distributive law. But it only applies in the special case where you're squaring X plus Y, or A plus B, or whatever it is. Okay. The other advantage of this is that often you can recognize that an expression has this form, so you can write it as a perfect square. Yes, I think I've got the back of this one covered, so. The other special product was X plus Y times X minus Y. And of course, that's X times X minus Y plus Y times X minus Y, which is X squared minus XY plus YX minus Y squared. Rewriting YX alphabetically as XY, we see it matches this except for the sign. So these two are equal and opposite. They add up to 0. All we are left with is X squared minus Y squared. Now this one is pretty easy to recognize. Okay. Here's an example. Write out all my words, and all you do is fill in the blanks here and here. Now, if you want to take it a little further to see where it's going, that's fine. But I want you to write out all those words and fill in the blanks for what X and Y have to be. Okay, well, it's not, well, forget what my sentence is going to be, but people had just a little trouble with this because they weren't quite seeing what was required, but it's very simple actually. Okay, so people were wanting to say that I'll write it over here. X equals 9R squared and Y equals 25S squared. This turns out to be a common problem. About half the class wanted to say this, okay? So you're looking at the right stuff. I mean, that's where X squared would go, and that's where Y squared would go. But if x equals this and y equals this, then x squared minus y squared is 9r squared minus 25s squared, which is 81r to the fourth minus 625 s squared. Not 9r squared minus 25s squared. Okay, so the problem with that is simply, if this is x squared, then x has to be whatever you would square in order to get this, right? Now, if I break it down and say, well, what do you square to get 9? People are going to tell me 3. What are you going to square to get r? Well, people are going to tell, well, you square r to get r squared. What are you going to square to get r squared? I'm sorry. And well, you're going to square r to get r squared. Okay. So that means x would have to be 3r. And y would have to be 5s. Okay. So if I repair this easily corrected error, I can tell you if x equals 3r and y equals 5s, then x squared minus y squared equals the square of 3r minus the square of 5x, which is going to equal what we want it to equal. Okay, so okay, so x is not going to be x squared. Okay, this says x squared minus y squared. If x equals what x squared equals, not going to work. Okay, x has to be the thing you square in order to get this. Okay, then go just a little more. I can say then x squared minus y squared equals x plus y times x minus y becomes 3r squared minus 5s squared equals 3r plus 5s times 3r minus 5s. Okay, that makes sense? Now, I'm going to give you another expression. I want you to write out all the words that I've written here, but replace x and y by whatever they need to be, right? So write out all the words. You're on the road, understanding this very clearly, okay? So, another example. Let's do this. There's one little twist in this that I think you're going to get. If you write out all these steps, then it's either going to make sense or it isn't, okay? I work overtime. Oh, man, we're having so much fun. Okay, I'm gonna finish this. If you need to leave, please feel free to just go out, behind the camera. Okay, so this is of the form x squared minus y squared with x equal to 4a squared. Now you write this out and then check. If I square this, am I going to get this? Because it's easy to write the wrong thing down here. It's easy to go too far and then take another square root. But somebody did that, which I thought was pretty good, but you didn't want to do. Okay, not going to work out. And then y equals 3b. Not negative 3b. You've already got a negative. You don't need a negative. If you square 3b, you get 9b squared, and you'll have negative minus, you'll have minus 9b squared. Then x squared minus y squared equals x plus y times x minus y equals 4a squared plus 3b, all that squared, times 4a squared minus 3b, all that squared. And then if you multiply this out by the distributive law, you'll find that you get this, which brings you full circle. So I would recommend that you multiply each of these out using the distributive law and check to make sure it works. If it didn't, you have immediate feedback. And you go back and you check. Does the square of this really equal this? Does the square of this really equal this? Did my clerical steps all make sense? Okay? This is booming, buzzing confusion when you do it after you've done 5 or 6 of these. You understand? And you review, take a test.